the next important piece of circuitry you're going to be looking at is SRAM, which is unlike ROM, it is actually writable too, which means we can use it for data storage and change it. And so here we have an address bit, which is essentially the word line. And then we also have the bit lines in and bit lines out, because we need to read and write. And so what's going to happen is each time we get each time the address is updated, it's only going to read from one of them at a time. So if address is knotted, it's going to read from address 0 here. And then all of the bit lines are going to be set to these. They're all going to be set to these SRAM cells. And if address is 1, then the bit lines are all going to be set to these address cells. And it's also important to note that we have to invert the output here, because in each individual SRAM cell, it stores the output as it stores the output on the other side. So we just have to invert it to get back what we put in. And so when we want to write to the SRAM, the write enable bit is going to go high. And then, for instance, if we have address 1, we're going to go in here. And so address 1 and 1. So that means it's going to set all of these write bits to 5 volts, which is then going to allow us to write whatever is on the bit line into these individual SRAM cells. And then at the same time, we're going to be able to read it out on the other side. Sorry about that. And so we can now look at individual SRAM cell. And so here we have the write bit. So like while bit line is in, it's going to gate this. And so if the bit line is high but write is low, it's not going to be able to allow us to force current onto here and change the results. But when write goes high, it's going to allow us to do that. And then we are going to invert it. So we're going to store the output over here. But because there is another inverter down here, it's just going to do this, and it'll just stay like this. And then whenever we want to read, we can just set 5 volts onto there, and it'll allow the inverted bit to pass through to bit line out. Yeah, an important consideration for this is the width to length ratios of the transistors, because we need this transistor right here to overpower this transistor here when we are attempting to switch the input. So we're going to need way more current in this one. And for a higher level picture of this, we get the SRAM address from the instruction. We have VDD. We have the mem write, or the write enable bit, and that also comes from the instruction. And then we have a mux here that is connected to all of the registers, and that'll allow us to load instructions in. So we have a select bit. And so when we want to write SRAM, or when we want to write register 00 to the SRAM, we need to set the address that we want to write to, and then we also want to choose which register, and then that'll pass it through here. And since write enable is on, it'll allow us to write to each of these individual bits down here. In order to simulate this, you can do a few things. You can make sure that it works with 1 bit here. Make sure it works there. That's very important, because if you know it works there, then you know you have your width to length ratios correct for this part. Otherwise, what you can do is you can set it all of these cells to 0 volts, and then switch them all to 1. And if that works, then you'll know you're golden. Another interesting thing you can do with this is you can parameterize your values, and you can use .ics or initial conditions to set into the bit that you want to store at the beginning. So if you're storing like 5 volts, and then you set the not bit equal to the opposite of that, so it'll be 0 volts, and then it'll start the circuit off like this. And you're able to store things dynamically this way, and it's very convenient for the whole SRAM circuit. And we also have the SRAM read outputs, which are from the bit line, and those go into a mux here, which goes into the register file later. And we choose between either the ALU or the SRAM to write to the register.